Hey guys, I'm going to go through three word problems from chapter 2, especially the ones from lesson 5 that we've been working on or started working on today. And I'm going to start with one that I was looking at with people in last period, which we ended with, which was really frustrating, so hopefully I can clear it up. But if you still don't get these word problems by the end of the video, don't get discouraged and don't get down on yourself because we'll spend time in class next time we meet working on just word problems and setting them up. And it's going to click eventually, so hopefully this helps. But the problem for those who weren't in class says bus fare for adults in the city is $1.50, the fare for students is $1. At one stop, twice as many students boarded the bus as adults. Is it possible that the total fares paid by students is the same as the total fares paid by adults? So, just starting off, I'm looking at this very last sentence, or the second to last sentence, because this is what tells me the very basic part of my equation. Is it possible that fares paid by students is the same as paid by adults? So I know I want to have students equal to adults. And I encourage you to write out the very, very basics and then turn it into an equation with math, because you need to understand what equals what. Now, I should really say price of students and adults price, because that's what we're comparing, the fare or the price for students and the price for adults. Now, how can you find the price of the students? Just in a very, very basic, don't even go back and try to put in the numbers or variables yet. I'm going to multiply the price per ticket times the number of students, right? That's my very basic formula. Price times number of students. For instance, if there's 10 students and the price was $2, how would I find the total price? 2 times 10. But we're going to plug in numbers in a second, and for adults it would be the same thing. The adult ticket price times the number of adults. Now, here's where I can start plugging in what I know. I know from the very first sentence that adults cost $1.50. And I also know that students cost $1. What I don't know is the number of students and the number of adults. That's what I need to form a variable for. Now, some of you are trying to just say, oh, let's plug in S for students and A for adults. But you can't do that because then you have two different variables, S and A. And if you have two different variables, you can't solve the problem. You can only have one variable. So we need to figure out what variable can I use that will work for both adults and students. So that's where this sentence comes in. At one stop, twice as many students boarded the bus as adults. Well, I know there's some number of adults, I don't know how many, and I know that twice as many of the students boarded. So if I know how many adults boarded, like let's say it said 10 adults boarded and twice as many students boarded, I would multiply 2 times the number of adults, 10, to find the number of students. So that's why I'm using A and 2A. And the reason I'm using this formula right here is because that's what I would use to find the student price and the adult price. I would multiply the ticket price times the number of students, ticket price times number of adults. And the variables I chose were A for adults, because I don't know how many, and twice as many, so 2 times A for students, because it says twice as many students. And I'm using one variable, I'm using just A, so that's valid, that works. And now if I solve this out, 1 times 2A is just 2A, and $1.50 times A is, I'm just really rewriting this, $1.50A. And to solve this, you would, well, you can't do anything. If I divide this side by $1.50 to get rid of it, and divide this by $1.50, okay, you should quickly see that this problem doesn't have an answer. No matter what I plug in for A, or A, it's not going to equal the same on both sides. Like if I plugged in 2 here, 2 times 2 is 4, 2 times $1.50 is 3, this is never. So this problem, after all that work, and I know it's a little frustrating, but it has no solution. There are no solutions to this problem because this side will never equal this side of the equation. But more importantly, this part right here, the setup, that's what I want to see you getting. I know you can solve this out. I'm not even going to finish it because I know you can solve it just using a calculator in your brains. But this part right here, setting it up, take the time to write out, start filling it in, and then use your numbers. Don't try to jump to the end just to be fast. And don't look at a problem and say, oh, there's numbers, I'm just going to try to solve right away, because it doesn't work like that. Even I still can't do it like that. So take your time. Another type of problem is this one, which this example I didn't do in any of the classes today, so we'll look at it real quick. You pay $25 to be a member of a discount club at a bookstore. Actually, I'm going to just jump to the end, which is what I'm trying to get you guys to do. Look at the end of this where the question actually is. Is it possible, and I'm starting right here, is it possible that the total cost of the books you could buy could be the same with and without being a member? So I want to know if purchasing with a membership and without a membership can be equal. So there's my very, very basic, I want to know if with can equal without, with a membership, without a membership. Now let's go to the problem. If you are a member, what are you paying? You're paying a $25 fee to be a member of the discount club, plus you're paying 8/10 per book. If you are not a member, what are you paying? And it doesn't say it, but you just need to think. It would be just B. You're just paying B the price of a book. So we want to know, is there any possible way that this and this can be the same? Can they ever be equal? So you can just start solving. I'm not even going to solve it, but there's your setup of the problem. I just wanted to see how it sets up. So there you go. If you want to try to solve it yourself, you can email me and with any questions or the answer for that, but there's your setup. $25 to be a member, plus 8/10 of the regular price of each book that you buy. But if you are not a member, you're just paying for the price of the book. All right. And we'll go on to the last one. This is the last type of problem we've been looking at, and these are the very wordy ones that a lot of us are getting stumbled on because there's so many words, but take your time. Don't read it once and say, oh, I can't do it. Read it again. Read it a third time. Pull out the information that you know. Obviously, there's going to be an equal sign in the middle, but what goes on each side? Here's my equal sign. Underline it, put an equal sign over it, whatever you need to do so you realize that this information is one side of the problem and this information is the other side. So 4 less than a number. Well, I don't know what the number is. I'm going to call it x, and 4 less than x means I'm taking away 4 from whatever the number is. So there's one side of the equation. So you can already eliminate part of the problem. Equals, now what does it equal? It equals 1/2 of, so 1/2 times, and times the sum of something. So sum tells me I'm going to be adding, so I'm already filling in an addition sign. And what is it? 2 times the number, which we're going to call x, that was what we called the number, and -8. Now that looks kind of sloppy because I've got plus and negative, so I'm going to just set that apart. But there's your very simple outline for this problem. 4 less than a number, so x minus 4, equals 1/2 of what? 1/2 of this whole thing, 2 times x plus -8. And then you can just solve this problem by distributing, simplifying, and solving. And obviously your answer could be there's one solution, there could be infinite solutions, many solutions, or there could be no solutions. It just depends on if you solve it correctly, which I'm not going to do because I didn't want this video to be a long one that has me solving a bunch of problems. I more so want it to be you seeing how to set them up and work through it yourself. So use these as models for your homework and any other ones you might want to try, and we'll go from there. I'm not sure when we're going to have class again, but hopefully Friday or even tomorrow we can start working on just word problems in class and get you more confident in your solving abilities. So if you have any questions, just email me. Hopefully this was a little bit helpful. Remember, you can always rewatch, rewind, pause it, try the problems yourself, and that's it. I will see you when I see you. Hopefully the snow doesn't keep us locked in our houses forever.